Hey everybody, this is Miss Weaver, and this is the first video for section 5.3. Alright, so in this video we are going to talk about independent events and talk about how we, find those probabilities intuitively. So we're not going to talk about formulas. And then in our second video, we'll look at an example with contingency tables and then talk about those at least probabilities. All right, so for section 5.3, the most important thing that we're really going to talk about is this idea of independence. And so that's going to be, ironically enough, one of the things that you'll want to be able to identify independently. So the idea of independence is the first thing that we'll talk about on the next slide. Again, as far as existence, we're not going to be using any of the formulas. We're not going to try and memorize those or even refer to those. We're going to look at an intuitive way instead when we're finding these probabilities. All right, so when we're talking about independent events, and this of course was in your interactive assignment, but we're talking about things that occur and do not affect the probability of the next event. And so it's not that it doesn't affect the event, but that it doesn't affect the probability. That's an important distinction. So one thing that is, is useful to think about if you're trying to determine whether or not something is independent is basically, does this outcome, the outcome that I get, so does my outcome change the possibilities? And so if we think about just, if I flip a coin, that coin doesn't remember that it landed on heads, and so that it will make sure and land on tails the next time that it's flipped. Same thing with rolling a die, 6-sided die, 10-sided die. It doesn't matter what, how many sides that die has. When you roll it and you pick it up, you still have 4 sides, 6 sides, 10 sides. And so you still have the same probability that's gonna happen. However, if you're drawing something out of a bag from a deck of cards, sometimes there's questions about, like, you've got jelly beans. If you choose a jelly bean and eat it, well, if you've eaten the jelly bean, then that you now have less jelly beans. So that's not independent. You now have your next probability will depend on that jelly bean that you just ate. Same thing with drawing marbles out of a bag. If you don't put that marble back in, you pull out a marble, and I don't know, let's say that it's a green marble. If you're holding a green marble or you set it down on the table, when you reach back into that bag, things have changed. The possibilities have changed. There are less green marbles. There are less marbles. And so the whole situation is different now. Depending on what probability you're looking for next, you may or may not care if there's less green. But you're definitely going to care that there's less marbles. So that's this idea of independence. So if we want to look at an example, the and probabilities, typically we're doing something multiple times. And we want to know what's the probability of getting, a set of results. So let's take an example where we flip a coin. And so here's my coin. I can't make it flip really cool like it does on StatCrunch. So if you've gone through that simulation, they make the coin actually flip, and they've got a really cool sound effect. I unfortunately do not have that, but I do have a coin. So there's our coin. And so let's say that I want to know what's the probability if I flip, let's say I'm going to flip 4 coins. So let me actually start over. So I'm going to erase that. And so we're going to say flip 4 coins. What's the probability that I get 4 heads? Well, that means I'm going to get, the first coin is going to be a head, And the second coin is going to be a head. And I'm trying to make this not look like the word hand. Maybe do this. And then we get, so 4 heads in a row. What's the probability that we get all 4 of the coins land on heads? Well, since they're independent, we can just multiply. And that's our intuitive way of doing this. Whenever we have a run of independent events, we just multiply their probabilities, and we don't have to worry about changing anything because it's always going to be a 1/2. So that's going to end up being 1/2, and then technically times 1/2 times 1/2 times 1/2. But there's an easier way for us to write that and for us to compute that with our calculators, and that's using exponents. So if we have repeated multiplication, you might remember this from school algebra class, and you may not. And if you don't, then now I'm telling you. But repeated multiplication can be simplified using exponents. So I can take 1/2 and I can raise that to the 4th power. And that's going to give me the same answer as if I just multiplied all those out. Now for 4, it might be quicker to just multiply 1/2 times 1/2 times 1/2 times 1/2. And that's perfectly fine. But if it were 10 coins or 20 coins, then I probably don't want to have to sit there and type out over and over and over again, multiplying that out so many times. So raising to a power, that just helps make that a little bit quicker. All right, so that's one example. Another example would be if we were going to roll a 6-sided die. So I've just got a picture of it there just for, fun's sake. And so let's say we're going to roll, let's play Yahtzee. So let's roll 5 dice. And I want to know what's the probability of getting Yahtzee. Well, if y'all haven't figured it out already, I enjoy games. Yahtzee is a game. If you've never played Yahtzee, I'm sorry. It is very fun. You should try it. But Yahtzee, you'd have 5 dice. And you roll those 5 dice, and there's a variety of different combinations that you can get. And interestingly enough, some of the names are similar to the names of combinations that you hear in poker. So you could have a full house, which is 2 of one number and 3 of another number. You could have a straight, which is just what it sounds like. You have all the numbers straight in a row. So either 1, 2, 3, 4, 5 or 2, 3, 4, 5, 6. And then a Yahtzee, that's the best you can get. That's the highest points. That is getting all 5 dice in the same, with the same number. So let's not just say Yahtzee because we can't do that yet. I'm going to change this real quick to say a Yahtzee, with, 6s, since I've got a 6 there on top of that dice. And I'll draw it out. 1, 2, 3, 4, 5, 6. So that means that what's basically the probability of me getting 5 6s? Well, just like above with flipping 4 coins, to get 4 heads, I would have had to get heads and heads and heads and heads and heads. Well, to get Yahtzee with 6s, then I need to know what's the probability of getting a 6, and let's see if I can make this go a little bit faster. Haha. And a 6. I can make that go even better if I copy the word 2. There we go. So there's 4, and we need 1 more. There we go. Move my little die up out of the way there. So, what's the probability of me getting a 6, and then another 6, and another, and another, and another? Well, the word "and" lets us know that we're multiplying. And so we need to know the operation, not the formula. So what that means, well, if I have a 6-sided die, then the probability of getting a 6 is 1 out of 6. Because there's 6 sides, they're all different. One of them is a 6, so 1 out of 6 gives our probability. So I'm going to do 1 out of 6 raised to the 5th power. And that's going to give me, I'm trying to remember from previous doings of this, I'm pretty sure that's it right there. Now, that's not the probability of getting a Yahtzee. So probability of getting a Yahtzee, interestingly enough, actually brings in what we learned in 5.2. So what I'm going to do is try and move, I'm going to cover up what we did here. And then I'm going to move my die up there. And then I'm going to take this and move it so we can still see it there. And then one more thing. Oop, yep, there it was. We'll bring that down. Okay, so that's our probability of getting Yahtzee with 6s. The probability of getting a Yahtzee, I'll do this in green, means that I'm going to get the probability of 5 1s, or I could get 5 2s, or I could get 5 3s, or I could get 5 4s, or I could get 5 5s, or I could write too big and run off the screen. Let me make that a little bit smaller just so we can, sorry, I'm trying not to be a perfectionist, but I'm ending up being a perfectionist. Or 5 6s. Well, now technically we only found the probability of getting 5 6s, but there shouldn't be any difference in the probability of getting 5 1s, because that would just be 1 over 6 to the 5th, or getting 5 2s, because that's going to be 1 over 6 to the 5th. So each of these, even though they are different outcomes, each of those have the same probability as the one we found. So does that, hopefully that makes sense. I was trying to ask you, but then I remember that you all can't actually answer me. So in order to get Yahtzee, we are going to have this number added. I'm just going to go ahead and say probability of 5 1s plus the probability of 5 2s plus the probability of 5 3s. And I'm going to use this wonderful thing we have in math, plus ... plus the probability of 5 6s, because I'm going to run out of space again. So it's basically just going to be 6, right? Because there's 1, 2, 3, 4, 5, 6 of them added together. Well, repeated addition is multiplication. So 6 times 1 over 7776, which should be 1 over 1296. Now, of course, decimals, especially with the online homework, decimals are perfectly fine. This is just a little bit easier to keep the exact number with the fraction. But that's our probability of getting a Yahtzee. And so if we take 1 divided by 1296, let's see here, it's actually a very small probability, 0.00077, and then like 16 something, so that's pretty good. And remember, anything less than 0.05 we've been considering unusual. So this is quite unusual to get a Yahtzee, and that's why you get the most points for it, because if you do manage, then it's pretty spectacular.